multiply both sides by a, and so you get a squared on the left equals ab on the right, and then they subtract b squared from both sides.
Okay.
Okay, and then on the left here, this is what's called difference of squares. This just factors into a minus b, a plus b. You would have seen that in algebra 2.
Mhm.
And on the right, you can factor out a b, which is a minus b here. Okay,
Mhm.
and this is where the error occurs. So the next step is you're dividing by a minus b.
Oh, I see.
Okay, and it looks okay, but since a equals b, a minus b equals 0, and
Mhm.
so you're dividing by 0 in this step right here.
Okay.
And so that's why I have to say which one is invalid. Dividing by 0 is invalid. It's right there.
Okay, makes sense.
All right, number 2 is a more this one's kind of in the language, the issues here with number 2. So and you see this again. This is you'll see this probably for the rest of your life. You'll see some variation on this. It says 3 students pay $10 for a ride to the local skiing mountain. After arriving at the mountain, the cabbie felt bad overcharging them for a $25 cab ride. So he decides to give $1 back to each of the 3 students, keep a $2 tip for himself. So the students each paid $9 for the cab ride plus $2 tip for the cabbie, total of $29. Where did the extra $1 go? Like if you actually laid out the money for this, you would see it, and that's what I think where this goes wrong. So here's what actually happens. So the cab company, they're actually getting $25, and the driver is getting a $2 tip. Okay.
Mhm.
So they're like, this is actually what is happening here, which and it's not that they each paid 9, it's that the customer 1, customer 2, and customer 3, they still have $1 in their pocket. So it's better to look at this from the perspective of where the money actually is at, not this sort of convoluted scenario. Basically, there is no missing dollar, I guess, is the point here. So like another way we can maybe look at this. I don't know if that still isn't clear. We can do it another way. I think let me try this out here. So to start, we don't know how much the customers have, but they have to pay the driver $25. They're not actually giving him $30, by the way. I think that's where the mistake is. They're giving him 25, and then they give a $2 tip. So it's like if customer 1, and customer 2, and customer 3, they each have $10 or 10 ones. From this grouping, they are paying 25, which means there's 5 left over. Does that make sense?
Yeah, okay.
Okay. And then they're also giving $2. We don't know how that happens. So that's 30 minus 25. That's 3. They still have $1 each. There is no leftover money.
Yeah, okay.
So that may be another way to sort of go through it.
Okay, that makes sense.
It's I mean, this isn't really math, by the way. This is like teasers.
Yeah. I think my teacher thinks he's a cool math teacher because he just gives us teasers instead of like long work or whatever. But
Yeah,
not
I
really.
think I think there's like a time and a place for this stuff. But maybe not what you guys are doing. Because you got real stuff to do here. You got a real statistics project to
Mhm.
do. All right. So for number 1 here on the statistics part, my question to you is are you allowed to use a calculator? Are you using maybe you'd like to use Excel, Microsoft Excel? Any of these are good options for us.
Yeah, we're allowed to use calculators. He doesn't have any restrictions, I mean, for the stuff.
Okay, so like the first few can all be done in a calculator. Actually, they all can be, but start with number 3. It requires using some tables and stuff, or maybe the calculator, but let me, I guess, ask, I mean, are you using a TI-83? What are you using here? Or what are you using for a calculator, if any?
I opened Decimos and I use that as like a scientific calculator or whatever. 'Cause
Okay,
it shows
um,
me all the numbers.
that's true. Let me just look at that real quick and see if it has any statistical stuff built in. It does. Huh. That's really interesting. I didn't know that it had that. It's not going to work for everything here. Trying to decide what we should do. Okay, for the first few, it won't matter. You really want to put the data in order to start out. 2.24, 2.25, 2.25, 2.26, 2.26, and 2.27. So that's the first thing to do.
Mhm.
So we're calculating, so the mean, you're going to add all the numbers up and divide by the number of numbers.
Right.
All right, now I'm going to use Excel, and I'm happy to show this to you. I'm only doing that because I want to redo the calculations. We're going to redo basically the same calculations a bunch of times. That's really
Okay.
the power of Excel. And if you want me to show you that, I can.
Yeah, that'd be great.
Okay, let me do that here. Just opening it here, waiting for it to load. All right, let me new share that and increase the size here a little bit. So first thing is I'm gonna just enter the data in. That's where most of the errors occur.
Mhm.
It's just putting the data in correctly. So now on the right here, I'm gonna write the word average or mean, median. And this is really the power of Excel. We'll be able to replicate this for multiple problems. So I'm taking the average of everything in column A,
Uh-huh.
which you'll see why with a larger data set, that why that's important. So there's your average or your mean. And then the median, same thing. You just type in this median function, you choose column A, and there's your median. Now why? Oh, because it's taking the average. Okay. Now, do you need to know how to do this by hand or just get the answer?
Just get the answer.
Okay, so there you go. There's your answers for that. The mode is going to be a little bit difficult on this one. I'll show you why in a moment. There's actually, so the mean, write that down, 2.255. Median is 2.255. So when I do the mode here, mode multiple, so there's Yeah, sorry. Didn't do that right. So there might be more than one mode, which is the case here. And see how they're help. It's giving me both modes.
Okay,
Mode is the one that occurs most often, but you've got two modes here because 2.25 and 2.26 occur twice. So you just gotta be careful. There's sometimes you choose the one that only gives you one of them instead of both. Okay. So that is 1A. I've written those down as well.
okay.
But my question to you is can we move on to B, or do we need to do the standard deviation? We do need to do the standard deviation. Okay, last one here. So I'm going to do that actually. We might have more than one mode. Okay, standard deviation. So it's a standard deviation of the sample. And that's where I assume your teacher wants the sample here. Let me go back and look at the problem. Okay. That's right here. So there's your standard deviation. Okay. To do outliers, it's a bit more involved. Meaning that I guess he just says, do you consider? So we would say no. There's no values that are sort of very far away from the mean or median. Is that okay? Clear?
No.
No. Okay. Let me do it a different way. So what I'm going to do here is I'm going to do a box plot of the data. I don't think Excel will do a box plot. Let me check here. Insert. Yeah, I don't think it'll do a box plot. Okay. All right, so I'm just going to copy some. You'll see some here in a moment. I'm just trying to make the graph here so that you can see it.
Okay.
Let's do a box plot. One. All right. Okay, so let me share a different screen. So I know you probably think, what is he doing? I'm doing stuff in the other screen, trying to get to where I can explain some of this.
Mhm.
So here is a box plot of the data. Okay, and it looks fairly uniform. I don't know if you can tell, like everything's kind of uniform about this center point.
Yeah,
Would you agree with that?
yes.
Okay, now I'm going to add in an outlier, and I'm going to redo the box plot.
Okay.
Why didn't it show me? Okay, there it is. All right, sorry, this didn't come out the way I wanted, but I added a data point 15.13, and what I was hoping to get you to see, which this didn't do a great job of showing, but maybe the issue is it's just too large. So I added a data point, and you can see here, see this little asterisk right here on the
Mhm.
right. So everything that I just graphed is now over here on the left. but this
Okay.
data point is really far away. It's really far away from the mean and the median. So an outlier is a piece of data that is very far from the mean or the median. Okay.
Okay.
Now, a better example of that real quick here is, and it doesn't happen so much in sort of the Southwest, but there's places in the country where you have a bunch of houses and they're all about the same.
Mhm.
And then you have a McMansion on the same street,
Yeah.
and that's an outlier. Okay.
Okay.
It's like everything else is kind of the same, and then you have this really odd, the thing there.
Right.
Occasionally in high school, it's like everyone's driving around kind of an older vehicle, and someone shows up in a brand new, Tesla. And you're like, wow, it's really different.
Mhm.
So that's what an outlier is. It's where it's very far from the other data points. Okay.
Okay.
All right. So for letter B, I'll snip that in here. I'm going to go right back to the Excel though. And after I snip this in, we're just going to enter the data points. And that's the power of Excel here. So let me switch screens to that. Is basically we get our answers, and you'll see that as I start updating the values. So I'm going to start typing in those numbers, 0.24, and see how the average, median, mode, they're all starting to change
Yeah.
as I do this. And that's what's really cool about Excel is it'll do the data manipulation on the go, and you can see everything update in real time. It's recalculating the cells. Now, another thing you can do in Excel that I think is pretty useful here is you can sort the data and put it into like smallest to largest. And there you go. And then it's a little more readable here. One of the reasons you might not do that is because you want to check that you've got all the data points and make
Mhm.
sure that if they're in order. They usually don't give them to you in order for some reason, but those look okay to me now. So you can see it did all the calculations for us. We don't have to redo anything. The mean is 0.215. The mode is, or the median is 0.21. The mode is 0.24. Standard deviation is 0.0477, we'll say.
Mm. On number 5, the 0.2, is that supposed to be there?
Yeah, it's the one that's 0.20. So another thing with Excel is that it doesn't always give you the data in the format you want. Like you can actually remove and add, sort of like play around with how many decimal places you want to show.
Mhm.
And so if it doesn't know any better, like if you put in 1, it's going to put in 1.00 instead of just
Okay.
one. It depends on what you're doing. So there's entire classes you can take on Excel, and I think they're very useful to know at least how to do a few things with it.
Mhm.
All right. So any questions on that?
Would you agree that there's no outliners? There's nothing really to.
Well, this one doesn't. I mean, this one doesn't ask for it, as far as I can tell.
No,
Is it? Oh,
so
it does for both of them. Oh,
yeah,
geez. Yeah. So they're
it's
kind
like
of the
an
same.
umbrella, like everything that falls
Yeah.
underneath one, you have to answer the question.
Yeah. I mean, there's like an outlier would be something like 2, number like 2, or a number like negative, you know, 3, um, on here, something that would really impact the values.
Mhm.
So another thing to think about that we didn't really discuss in this problem here is units. So in the previous problem, the mean has a units, the median has a units, the mode has a unit, and the standard deviation has a unit.
I see what
And
you're
we
saying.
should include that here.
Okay.
And then this other one though, blood alcohol content, I don't know the units of blood alcohol content. I assume it's something like percent alcohol per something, but
Right,
um,
but it doesn't give us anything, like, for
it does
example, grams.
it does not. Yeah.
Okay. mean, I would say it's like ounces or something, but like, no.
Yeah, I mean, you can check your, the state driver thing and find that out. So, here we go. New one here. I'm going to go back to Excel and start entering these values. All right, so got the mean of 0.8, the mode 0.81, and the median 0.81.
Uh-huh.
And then the standard deviation is 0.0129. And these are all in pounds. So you want to update your.
Mm. 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 0.0129. Okay. Got it.
Okay. All right, so question 2. All right, in each case, state whether the mean or median would give a better description of the average. Okay, so let me give you a really small example here. Let's say you had 3 numbers, 1, 2, and 3.
Uh-huh.
What is the average of these 3 numbers?
It's all of them added together and then divided by 3.
Right, so 1 plus 2 plus 3, that's 6, divided by 3 is 2. Okay, so
Mhm.
the average is 2. The median is the middle number, which is also 2. Okay.
Right, okay.
Now let's take a new set of numbers, 1, 2, and 15. Okay.
Mhm.
The average is now 6, and the median is 2. Okay.
Okay.
Now, do you see that 2 of the 3 values are still pretty close to 2?
Mhm.
So the idea here is that the average is influenced by extreme values. And that was the illustration of the McMansion here.
Uh-huh.
You've got 4 little houses and then a big house. Like, these are the more representative of the neighborhood. Okay.
Right.
So the idea here, and this is very important, is that the average is influenced by outliers.
Mhm.
Okay. And so when we answer these questions, we have to ask ourselves, are there outliers? That's really what this is asking. Are there outliers? Meaning like big exceptions.
Right.
Okay. And so the first one, the average household income in Washington, you don't know this because you just, of course, you just haven't been on the planet long enough, but they always use the median. And the reason is there are people that make a lot of money, a lot of money,
Mhm.
and that heavily influences the average. But that's
Okay.
not where most people don't live on the average. They live on the median. You'll see
Right.
this, the median income, is in this country, I don't know, it's probably closer to 57, 60,000. It was around 50,000 for a while. It's
Mhm.
gone up recently. So median income is a better estimate because, yeah, there's outliers. Okay, now let's go to one that is for sure an average. The average weight of potatoes in a 10-pound bag. They're going to be more or less around 10 pounds. That's what an average means.
Mhm.
Okay. And I'm not doing a good job explaining my reasoning, but median, uh, um, high income earners, will say.
Okay. I put the question, are there outliers? And then I put medium equals, yes, there are.
Yeah, explain your reasoning. I mean, just a little bit more. You want to indicate that you know why, which is that, yeah, there's people who make a lot of money, and there's nothing wrong with that. It's just that it skews the people that are making kind of the typical salary.
Yeah.
Like, you're working right now. Is that right?
Not currently,
Oh,
no.
not currently. Okay, you mentioned that a few weeks ago. That's why I asked.
Yeah.
And when you are working, you're generally making what everyone else makes around you. You're not making, 10 times as much.
Right.
That's the way it goes. Now, when you go to the grocery store and you buy a 10-pound bag of potatoes, there better be 10 pounds in there. You're gonna be kind of frustrated.
Yes.
I mean, we know how that is. I mean, occasionally you buy something and it's half of what you think it is, and you're like, I'm not paying for this so this
Bag
is
of
where,
chips. That's when it happens, when you buy a
well,
bag of chips.
that's yeah, I don't get, yeah.
It doesn't make sense.
Cereal's not real good sometimes as well. You
Yeah.
got, yes, bag of chips is a good one though. Yeah.
Mhm.
So that's an average because you would expect everything to be around the same value. Like
Yeah.
every 10-pound bag should be about 10 pounds.
Uh-huh.
And I don't know how you say that. Okay, let's go to B. I think B is a tough one here because it depends on whether you think a lot of men wait to get married until they're much like later in life. Like we would say that it's probably rare for anyone to be under 18 to get married.
Right.
I don't even know if that's possible. And the question is, well, how far like would a man wait? And I don't know why they're choosing men, but they are. Um, Yeah, you could ask that. Maybe it's different for women, but I mean, if you want, since I'm the only male in this Zoom call, I will say that it's unlikely. Like men don't wait. Like I would say, it's maybe the exception. I mean, we'll say maybe 35, but this is pretty good window. They're
Mhm.
not waiting until 72 to get married.
Yeah.
That's just not happening. So I would say probably average
Okay.
here. And you want to use some sort of reasoning like that.
Mhm. Okay.
Okay. Jack in the Box. Do you go to Jack in the Box?
Yeah.
Great. So you've been there. You've probably been there when you go right up, place your order, they've got it for you, and you head out, right?
Yeah.
And I guess I would have chosen Starbucks, but maybe that's
That's a better one because those ones, they can be like crazy.
yes, yeah. Or if the first time In and Out comes to your town, and this is when I was in so last summer I was in Colorado for a while, and there was a Cane's Chicken, and I guess
Mm.
it was a big deal, and I mean, they were lining up on the street, 30 40 cars deep, and you're like, what's wrong with you guys? Go to Walmart and get some chicken strips. But
I love Chick-fil-A, like the videos where they show Chick-fil-A and it's
yes,
Sunday, and I'm like,
can't go.
70 cars. I'm like, what?
Yeah, it's the same deal. So it could be one car, it could be 20 cars, right?
Right.
And so the question is, well, what is more likely? It's probably, when you go there, there's probably going to be 5 or 6 cars in line.
Mhm.
So we would consider 20 cars an extreme value,
Mhm.
if you go on a Friday night. So we would want to use the median here.
Okay, yeah, that makes sense.
Okay, there's probably 5 or 6 cars. I hope there's not 20, and you feel great when there's only one in line.
It depends how much you really want that thing, Jack and Box.
That's
Am
right.
I gonna wait in the line for 25? Probably not.
I hope not.
Okay. Instead.
Okay, so the next two problems here switch to what's called the normal distribution. You've probably heard the bell curve,
Mhm.
grading on the bell curve. Um, you've probably seen something like this before.
Rarely do my classes actually do grade on a curve, but I've had it.
Well,
Um,
you might not like it because if you're on the wrong side of the curve, your grade could go down.
Yeah, no, I haven't liked
They
it.
don't tell you that.
It was chemistry, and I'm like, this is awful. I had
Yes.
a hard time in chemistry.
All right, so it says your scores on a math exam were normally distributed with a mean of 67% and a standard deviation of 8. Use this information to determine which of the following. So if 67 is the middle value, they're asking you what is the area in this curve to the left of 75. Okay.
Oh, okay.
Now we're gonna do this. And your calculator's okay on this? Is that right?
Yeah, that's fair.
Okay, so I'm going to go to the Excel again because this will help to make this faster, and I'll send you the Excel at the end as well.
I know we're kind of running out of time. I feel bad.
That's all right. We're going to get these done. Don't worry. But,
Mhm.
okay, so the mean here is 67, and the standard deviation is 8, and the what's called the X value is
Okay.
75, and we want what's called the left tail. Okay,
Mhm.
so to do this, it's the normal distribution mean. See how it's asked for the mean, standard deviation.
Yeah.
I'm sorry, it first asks for the X value, the mean, and then the standard deviation. And then this is true. Don't worry about why that is. That is your answer for part
Okay.
A. For part A, 0.8413.
Okay.
All right, so we'll have to go back and forth here a little bit. So part C, we can do the screen. Wait, part B. Or, oh, sorry, what? Okay, sorry. So part B, I did this right. All right, what percent of the exam scores were above 83%? So I'm going to go back to the Excel,
Mhm.
and you're going to see how, again, like kind of the power of the Excel here. So the left tail is 0.84. The whole area under the curve is 1. So if I subtract this number from 1, those two add up to 1 here. So the only thing we're changing here is the X value, this 83, and see how those values update.
Mhm.
So the right tail is 0.02275. That's the percentage of exam scores above 83%.
These are not very good odds.
Yeah, that's a good point. That's what, why is the exam so tough?
Yeah.
Let's go back to the other screen here. So it says a failing grade on the exam, anything more than 2 standard deviations below the mean. So the mean was given as 67. So
Mhm.
you're taking 67, you're subtracting 2 times 8, which is 16. So a 51 was a failing grade.
Right.
Okay. Now I won't share the screen just because it takes so long to go back and forth. But
Mhm.
the percentage of students that failed when I put 51 in for X is also 0.02275. And that's what's meant by the curve. You still have people that fail. So it's not
Right.
always such a good thing to grade on the curve. All right,
Okay.
so I'm going to illustrate these 3 graphically, and then we'll go to the Excel here. So this is 67. Here's
Mhm.
80. We're finding all this area to the left. Okay.
Got it.
The next one is 67, but this time it's between. It's 63 to 83. We're finding the area between.
Okay.
Okay. And then the last one here is the same thing. It's a between situation. 60 and 72. So not to scale, but we're going to do those 3 in
Mhm.
the Excel here. So let me do that for you. Show you how to do that. A lot of statistics classes pair like Excel or StatCrunch or all these different statistical softwares with the class, but doesn't
I
look like
wish my teacher would have done that. He didn't say, hey, Excel would be a good resource right now.
yeah, just struggle. That's a good strategy. Yeah. Okay. So again, what part D, about what percent of students were below 80%? So that's the left tail. That's the left of that number. So you can see it's 0.9479. Okay. So we do not have a between yet. So here's how we're going to do between. How am I going to do this? So we're going to get the ones below 83, okay, which is 0.9773, and we're going to subtract. Okay, so I'm writing this number down, but we're going to take this number right here and we're going to subtract the ones, the 63, which is 0.3085, and we're going to just subtract those values. Okay, so I'll share that in the other screen here in a moment.
Okay.
So it ends up being 0.6688 roughly. And then we there's another one here, at least 60 and at most 72. So I'm going to first do the larger one. It's always the right minus the left. 72 is 0.7340 minus, let's put the 60 in, 0.1908. Okay, 0.1908. So I'm going to go subtract those. All right, so let me go back to the other, where are we going to, going back to this other one? Okay, sorry. And sometimes it's like mystery of what is Matthew even doing? I was writing things down to help you here. So those numbers I got, the 97 comes from the 83%, and then the 63 comes from that one, and then you subtract. Okay, and the idea is like you've got all the area to the left and all the area to the left. So when you subtract it, it cancels out this overlap.
Okay.
And then same thing down here, you do the right minus the left.
Okay.
Okay. Now, one other thing here that I just now noticed is it says about what percent. So we need to actually convert all these to percentages. So it's 94.79%, 66.88%, 54.32%. And I'm going to go check the other ones to see that I didn't fumble those with what we needed. Okay, so they do ask for percent and all these. So we're going to go back up and adjust those as well. So this is 2.275%. This is 2.275%. Adults like percentages. This is 84.13%. Like you go into a business meeting down the road, or you go work somewhere, you never use decimals, you always give percents.
Okay.
It's just a thing,
Mhm.
which is really weird. And like, you know, in the banking world, it's like, yeah, they always talk about percents, but the calculations are all done with decimals. So it's, you know, maybe, I don't know. That's just a sidebar. So any questions on that before we move to 4, which is gonna be really similar?
No.
Okay, all right. Yeah, maybe a good email is to send the instructor, say, hey, you know, I was working these problems with Excel and want to just, you know, find out, you know, if you recommend anything else, or, you know, maybe get some feedback on that.
Right.
All right, when a woman learns she is pregnant, her doctor calculates a due date for the baby. This is completely true. The due date represents the date in which the baby will be born. For pregnancy lasts the mean of all length of all pregnancies. Actual lengths of pregnancy turn out to be normally distributed about this date, with a standard deviation of 15 days. I don't know about that part, but I do know that they do use probability to estimate due dates. So
Yeah, I was a day late and I was a premature baby. So whoever was calculating me was not on you at all.
yeah. Well, I think because it's like human life, we're not always predisposed to probabilities when we when we are ready to get into the world.
Yeah.
All right. So this one is, I guess it's slightly different. Yeah. Okay. So notice they're not giving you the mean days. I don't actually know what it is, but I mean, it's around 9 months. So whatever
Right,
that
okay.
has 270, but that doesn't matter because what they're using here is what's called the empirical rule.
Mhm.
Actually, I'm not even going to draw. Yeah, let me actually draw it. So whatever the mean is, they're saying that 15 days is a standard deviation. So they're
Mhm.
saying within -1 standard deviation and +1 standard deviation, they're asking what is that area.
Oh, okay.
And it's not that difficult to calculate if you know the empirical rule. And I'm looking for a nice graph for me to snip in to show this to you. Yes. This one will be okay to start, I think. Let me we'll get through everything. Don't there. So here it is. So this I don't know what color is this middle, would you say?
Pink.
Pink. Okay, so the pink region here is -1 standard deviation and +1 standard deviation. So the answer is 68.27% in your problem.
Okay.
All right, now part B, we're going to use the same picture. About what percentage of the births occur within 1 month of the due date? Assume 30 days or 2 standard deviations. So they're saying how much area is between here, and that's this line.
Oh, okay.
So it's 95.45%. Okay, which is pretty good.
Mhm.
Okay, I mean, I don't know. That could be a lot of time, but that's that's a different question, a different class altogether. So C, more than 3 weeks before the due date. So this one's a little tougher because we have to know how to calculate the standard deviation here. So the
Mhm.
3 weeks is 21 days. So it's 21 days divided by the standard deviation. Okay.
Mhm.
And when we do that calculation, 21 divided by 15, we get 1.4. So what you're looking for on the normal curve here is assume that the mean is 0, a normalized mean,
Mhm.
or this is negative. So they're basically asking what is the area left of this minus 1.4.
Okay.
All right, and you can get that using Excel. And that is not gonna happen. Okay, and that so that ends up being 0.0808. So we'll say 8.08%, like that.
Okay.
And so by symmetry, D is the other side of that. It's 3 weeks late. All right. So in terms of like what's going on there, this time it's instead of being -1.4, it's positive 1.4.
Okay.
And this is where this is where I'm not sure, because I would think there's some health risks if you wait that long. But this is
Right.
also 8.08%. So I know that maybe like this is where the math and the science, don't always intersect, because or the health of the child is like, maybe we don't want to wait. I don't really know. I'm not a doctor. I don't play one on TV. Okay. About what percent of births occur more than 15 days before the due date? So here, 15 days is one standard deviation below, and they're asking
Mhm.
for this area to the right. And we
Okay,
actually can get that from this picture again. Actually, that's not a good picture. Let me find another one. This is a better picture for this. So the question goes on to say, is it safe to fly, and other things like that. And what you're basing it on these models where, so the answer here is to add up everything to the right of this one standard deviation. So
uh-huh,
34 plus 34 plus 13.5 plus 2.35 plus 0.15, and you end up getting, what is that? 2.5, 68 plus 2.5, 14, 16, 84%. Okay. So what they're basing this on is it a good idea for pregnant to fly? Important meeting 15 days before the due date. They're saying that there's a 16% chance that she could give birth 15 days before, but most of the time she won't.
I feel like that's wrong, but like scientifically, but yeah,
Yeah.
I see what you're saying, like that's what.
So the answer to the question really is like comes down to like, do you want to take on that much risk? I think they, I mean, I think it's even, I would say it's more over here where they cut off, flying and stuff like that.
Yeah.
I don't know. Okay, I know that was a little bit rushed, but hopefully that was helpful today.
Mhm.
I know we got through everything, but
We missed one